Have you ever pondered about life on Mars? Well, let's embark on a fascinating journey to the fourth planet from the Sun, a celestial body that's stirred up intrigue and wonder for centuries. Mars, often referred to as the Red Planet, earns its nickname from the iron in its soil. This iron, when it rusts, infuses the planet's surface and atmosphere with a distinctive reddish hue. Much like our own planet, Mars is a terrestrial world, boasting a hard, rocky surface beneath its rusty exterior. But don't let its Earth-like characteristics fool you. This planet is a world all its own, starkly different from our home. And one of the stark realities of Mars is its climate. Mars, despite its warm appearance, is a frigid place, with an average temperature of negative 62 degrees Celsius. A stark reminder that appearances can be deceiving, even on a galactic scale. Mars is a planet of extremes, from its moons to its weather. Mars has two moons, Phobos and Deimos, both of which are far smaller than our own moon. Phobos, the larger of the two, is so close to Mars that it orbits the planet 3 times a day. Its name comes from the Greek word for fear, a fitting name for a moon that is slowly but surely spiraling towards Mars, and will one day crash into the planet or be torn apart by its gravity. Deimos, on the other hand, is named after the Greek word for terror. It's a bit further out and takes about 30 hours to complete an orbit. These two moons, while small, add to the eerie beauty of the Martian night sky. But the drama doesn't stop there. Mars is known for its colossal dust storms, some of which can envelop the entire planet and last for months. These storms are fueled by the thin Martian atmosphere and the planet's distance from the sun, which creates temperature differences and strong winds. The dust from these storms can rise up to 60 kilometers into the atmosphere, turning the Martian sky a hazy orange and blocking out the sun. These dust storms, combined with the planet's 2 fearfully named moons, make Mars a truly dramatic and dynamic planet. The Red Planet is not just a static, silent world, but a place of constant change and movement. These dust storms make Mars a truly dramatic and dynamic planet. Time and gravity work differently on Mars. This statement might sound like a line from a science fiction novel, but it's a reality we have to face when we talk about the Red Planet. Let's start with time. A day on Mars, known as a sol, is just a smidge longer than an Earth day, clocking in at about 24.6 hours. So, if you're a fan of those extra few minutes of sleep in the morning, Mars might be the place for you. However, a Martian year is a whole different story. It lasts 687 Earth days. That's almost twice the length of our year. Imagine celebrating your birthday just once every 2 Earth years. Now let's talk about gravity. It's a force we're all familiar with, but it's much weaker on Mars. In fact, it's only about 38% of what you'd experience here on Earth. This means you'd feel much lighter, and you could jump almost 3 times as high on Mars. It might sound fun, but it also has serious implications for the human body. We evolved under Earth's gravity, and a sudden shift to Mars' weaker pull could lead to muscle and bone loss. But it's not just our bodies that would be affected. Weaker gravity also means that Mars can't hold onto its atmosphere as well as Earth can. This leads to a much thinner atmosphere, which is one of the reasons why Mars is so much colder than Earth. And of course, this has implications for any potential manned missions to Mars. Astronauts would need to train to cope with the weaker gravity, and we'd need to develop technology to protect them from the harsh Martian environment. On Mars, you would experience time and gravity in a way that's alien to us on Earth. But with every new piece of information we learn about the Red Planet, we're one step closer to making those science fiction dreams a reality. Breathing on Mars would not be as easy as it is on Earth. On our home planet, we enjoy a rich, oxygen-filled atmosphere that supports life as we know it. But if we were to step foot on Mars, we would find ourselves in a very different situation. The Martian atmosphere is incredibly thin, about 100 times thinner than that of Earth. This means that the air pressure on the surface of Mars is significantly lower than what we're used to. Imagine standing on top of a mountain that's 3 times the height of Mount Everest. That's what being on Mars would feel like. But it's not just the thinness of the atmosphere that poses a challenge, it's also what it's made of. The Martian atmosphere consists mostly of carbon dioxide, with only trace amounts of oxygen. In fact, oxygen makes up only about 0.13% of the Martian atmosphere. This is a far cry from the roughly 21% oxygen content that we enjoy on Earth. These conditions mean that humans cannot breathe Martian air. We would need a spacesuit with an oxygen supply whenever we venture outdoors on Mars. And this isn't just about breathing. The thin atmosphere also offers little protection from harmful solar radiation, another reason why a spacesuit would be necessary. Despite these challenges, the Martian atmosphere is a source of fascination for scientists. It holds keys to understanding the planet's past and future and possibly the potential for life. The Martian atmosphere, though thin, is one of the many elements that make Mars a fascinating planet. Humans haven't set foot on Mars, but we've sent our robotic ambassadors. Our exploration of the Red Planet began in earnest in 1997, with the landing of the first Mars rover, Sojourner. The size of a small microwave, Sojourner was our first mobile emissary to Mars. Its mission, to demonstrate the feasibility of low-cost landings and roving explorations on other planets. During its 83 Martian days of operation, Sojourner transmitted over 500 images back to Earth and performed chemical analyses of rocks and soil. Fast forward to 2004 and we have Spirit and Opportunity, twin rovers designed to search for and characterize a wide range of rocks and soils that hold clues to past water activity on Mars. Spirit lasted until 2010, while Opportunity persevered until 2018, both rovers far outlasting their original 90-day mission lifetimes. Then came Curiosity in 2012. Armed with a suite of sophisticated scientific instruments to explore Gale Crater's intriguing terrain. It discovered that Mars once had conditions suitable for life, with evidence of ancient streams and lakes. And now, we have Perseverance. The most advanced rover yet, it landed in February of 2021, tasked with searching for signs of ancient microbial life and collecting samples for future return to Earth. Perseverance also carries with it the Ingenuity Mars helicopter, a technology demonstration to test powered flight on another world for the first time. As we speak, Perseverance is diligently carrying out its mission on the Martian surface, sending back invaluable data and stunning images, helping us better understand this alien world. Each rover, from Sojourner to Perseverance, has built upon the success of its predecessors, expanding our knowledge and bringing us one step closer to possibly setting human footprints on Martian soil. These rovers, our eyes and ears on Mars, continue to unravel the mysteries of the Red Planet. Could there have been life on Mars? This is a question that has piqued our curiosity for years. In 2018, NASA's Curiosity rover found signs that suggested there might have been life on the Red Planet. The rover discovered complex organic molecules, the building blocks of life, which could provide evidence of past life. But these findings are not enough to confirm the existence of life. They merely suggest that the conditions necessary for life once existed. The molecules might have formed from non-biological processes, or they could be the remnants of ancient Martian life. This is where Perseverance comes in. This rover's mission is to dig deeper, literally and figuratively, into this hypothesis. Perseverance is equipped with a drill to collect core samples of Martian rock and soil. These samples will be stored in tubes on the Martian surface, awaiting a future mission that could return them to Earth for detailed analysis. By studying these samples, scientists hope to find definitive evidence of past life on Mars. Perseverance is also tasked with characterizing the planet's geology and climate. This information will help scientists understand the environmental conditions on Mars when the organic molecules were formed. This, in turn, could provide insights into whether these conditions were conducive to life. The rover will also test new technologies that could be used in future robotic and human missions to Mars. These include the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, which will attempt to produce oxygen from the Martian atmosphere. This technology could provide breathable air for astronauts and propellant for rockets. The possibility of once having life on Mars continues to entice us, encouraging us to explore and understand more about our intriguing neighbor. As we delve deeper into the mysteries of Mars, we're not just seeking answers to our questions about the Red Planet. We're also seeking a greater understanding of life itself, where it comes from, how it evolves, and where else it might exist.